Trig Homework 5 starts off with solving a linear equation with several occurrences of the variable, variables on both sides, and fractional coefficients. We know that whenever we have fractions in our equation that we could subtract the x and add the 4/3, but then we end up having to add and subtract fractions, and then we have to get rid of our coefficient by multiplying by the reciprocal, and there's a lot of room for error. So another way to solve this problem is to get rid of the fractions first. And in fact, when we have variables in the denominator, we have to get rid of the fractions first, so it's just a good practice to do. So in this case, I have denominators with 3's and 4's. My least common multiple is going to be 12. I'm going to multiply each term by that least common multiple to eliminate my fraction. So I'm going to multiply by 12 here, by 12 here, even times the x, even though there's not a fraction, but every term has to be multiplied by that 12. The ones with the fractions, I'm going to do some canceling. These should all go in evenly, otherwise you have the wrong common denominator. 3 goes into 12 4 times. 4 times 7x would be 28x. 3 goes into 12 4 times. 4 times negative 4 is minus 16 equals 12 times x, 12x, and 4 goes into 12, 3 times 3 plus 9. I now have gotten rid of my fractions. When I multiply by the common denominator, I'm always going to use a positive value, so the signs in front of each of your terms should be the same as they originally were. None of those should change until this step. Now I want to go ahead and solve my equation for x. So I'm going to go ahead and subtract my 12x to move that to the left side and add my 16 to move it to the right side. Doesn't matter which side you move which things to, just as long as you move them to opposite sides. I usually move the variable to the left and the number to the right. So 28 minus 12 would be 16x. 9 plus 16 would give me 25. I can then go ahead and divide. And if I have 25/16, I don't believe I can reduce that down. So 25/16 is just going to be my answer. So in number 2, if I look at my denominators, I've got a 3, a 2, and a 6. My least common multiple would be 6. Now if you happen to use 12 or 18 or something else that all of them divide into, it will work. Your numbers will just be bigger. So to use the least common multiple is the easiest one. I'm going to multiply everything times 6 so that I can then eliminate my fractions. Now of course we don't have a fraction on the first one. 6 times 7y is just 42y. Minus 3 goes into 6 2 times 4, so minus 8 there, equals 2 goes into 6 3 times 5y, so 15y, and 6 goes into 6 1 times minus 7, minus 7. So if we're going to solve this, I'm going to go ahead and subtract my 15y and add my 8 to move that over to the other side. So 42 minus 15 is going to give me 27y equals 1 then. And then if I divide by my 27, y equals 127. Number 3, same kind of thing. I'm solving that for u. My common denominator in this case, since I have 5's and 3's, would be 15. So I'm going to multiply each term by 15, sneak my 15's in there. So I have to start out by doing 15 times 5, which gives me 75. I don't know what I'm writing. 75u. And then canceling. 5 goes into 15. 3 times my 1 would be 3. 5 goes into 15, 3 times my 2u would be 6u. 3 goes into 15, 5 times 4, going to give me 20. I want to go ahead and solve that, so I'm going to subtract my 6u and subtract my 3. So 69u is going to equal 17, and then of course dividing u equals 17 over 69. And I don't think I can reduce that down. I'm going to double check, but just to be sure. And here I'm checking with my calculator. If I put in 17 over 69, it still gives me 17 over 69, so I know I can't reduce it. So that's going to be my answer. So 4, 5, and 6 say solving a linear equation with several occurrences of the variable fractional forms with binomial numerators. And again, we got fractions there. So if we have fractions, we want to multiply by our common denominator. So in the first one, if I have an 8 and a 2, my least common multiple is going to be 8. So I'm going to multiply every term times 8. And so what's going to happen here, 8 times 9 is 72. That's going to equal, and what I'm saying is 8 goes into 8 one time, so I'm taking 1 times the 9y plus 5. Plus 2 goes into 8 4 times, so I have to take the 4 times the y minus 6 and use my distributive property. So 72 is going to equal 9y plus 5 plus 4y minus 24. Next thing I'd probably do is just go ahead and combine my like terms that are on the same side of my equation. So simplifying this, 72 is going to equal 13y minus 19 then. I'm going to rewrite that over here. So if I'm going to solve that, I have to add my 19 to the other side. So if I add my 19, 91 equals 13y, and then of course I'm going to divide by 13. Now the nice thing about these problems is they should all come out to nice whole number answers. So 91 divided by 13 is 7. If you get something that's not a whole number answer, you know that probably you did something wrong and you should go back and check your work. So if I look at number 5, again I have a denominator of 8 and a denominator of 4, so my least common multiple is 8. So I'm going to multiply by 8, multiply by 8, multiply by 8. 8 goes into 8 one time, so 1 times my 5v plus 4, which is just going to be 5v plus 4, equals 9 times 8 is 72, minus 4 goes into 8 2 times. So I'm going to take minus 2 times the 4v minus 5. So I am going to get 72 minus 8v plus 10. You have to be really careful with this sign that you distribute it out. And that's why I like to put the parentheses there so I don't forget, oh, there was a minus sign in front of that fraction, and I get the right signs. 5v plus 4 then is going to equal negative 8v plus 82 if I can combine my like terms. So I'm going to go ahead and rewrite that. 5v plus 4 equals negative 8v plus 82. I'm going to add my 8v and subtract my 4 in order to solve that. So 13v equals 78, and then I'm going to divide by my 13. Again, 78 divided by 13 should come up to a nice whole number. It does. It goes in there 6 times. So v is going to equal 6. So number 6, same kind of thing. This time I have denominators of 6 and 7 that don't have anything in common, so I just have to multiply them together and use 42. It's not a real easy number to work with, but probably better than the alternative. So I'm going to put 42 times each of my terms. 6 goes into 42 7 times, so I have to take the 7 times the 5x plus 4. 7 goes into 42 6 times, so I'm going to take the 6 times the 2x plus 8. And then I have to take 5 times 42, which I believe is 210, but I'm going to check for sure. Yes, 210. So 35x plus 28 is going to equal 12x plus 48 plus 210. So 35x plus 28 equals 12x plus 258 when I combine my like terms there. I have to minus my 12x and subtract my 28. I get 23x equals 230, and if I divide by my 23, x is just going to be 10. Seven, 8, and 9, solving equations with 0, 1, or infinite many solutions. We're used to solving all our equations and getting W equals an answer. But there are some times when your variable could equal any number in the world, and they always would end up being equal on each side, or that when you get when you try to solve it, you're never going to get an answer that works. So we're going to solve these like we solve everything else, or at least we're going to start that way. And so we're going to multiply this out. 5w plus 5 minus w equals 3w minus 3 plus 7. Here, 5w minus w is 4w, so 4w plus 5 equals 3w plus 4. This one is going to solve like it normally does because I can tell my coefficients are different numbers. It's only going to be when your coefficients are the same numbers on opposite sides that they end up canceling each other out. So in this case, I'm going to subtract my 3w, subtract my 5, and I'm going to end up with w equals negative 1. So they're going to have you click in this circle, type negative 1 over here, and put your solution in. Second one, using my distributive property. 3w minus 6 minus 5w is going to equal negative 2w minus 4. Combining my like terms, 3 minus 5 is negative 2w minus 6 equals negative 2w minus 4. Now this is one where you're going to have one of those special cases. When I solve this, I'm going to add my 2w and add my 6. I get 0w equals 2. Can 0 times anything equal 2? Well, no, it can't. And so this one's going to be no solution. The only way it's going to work is if 0w equals 0, because 0 times any number is 0. That's when you get the all real numbers are solution. But if you have 0w equals anything other than 0, 2 in this case, I can't take 0 times anything and get 2. No solution is going to be my answer. So number 8 is going to be the same kind of thing here. We want to solve each of those. And so using my distributive property, negative 3w minus 3 plus 7w equals 4w plus 4 minus 7. Combining my like terms, 7w minus 3w is 4w minus 3. Then I'm going to get 4w, 4 minus 7 minus 3. Notice on this one I have the exact same thing on both sides. If I would go about solving it, I would subtract my 4w and add my 3. I get 0w equals 0. 0 times 1 is 0, 0 times 2 is 0, 0 times 15 is 0, 0 times negative 983 is still 0. So in this case, you get the all real numbers are solutions, and so we would just go ahead and mark that circle there. Second one, we're going to use our distributive property again. Negative 3w minus 12 minus 2w equals 2w plus 2. So we will get negative 5w minus 12 equals 2w plus 2. Again, I can tell this is going to solve because my coefficients are different, and I'm going to go ahead and finish it if I can pick up my pencil. So minusing my 2w and adding my 12 gives me negative 7w equals 14, and when I divide, I get negative 2 for my solution. So I check that middle one, type -2 over there after the W equals. Number 9. Same kind of thing. I want to solve each of those. So on the first one, using my distributive property, 4x minus 12 minus 6x equals -2x minus 12. 4x minus 6x is -2x minus 12 equals -2x minus 12. You might remember from the previous one that looked like that, where everything was exactly the same on both sides, that when you solve it, you get 0x equals 0, and that if you get that, all real numbers are solutions, because 0 times anything is going to give you an answer of 0. And the second one, 4v plus 4 minus v is going to equal 3v minus 3 plus 3. So we are going to have 4v minus v is 3v plus 4. Here, -3 plus 3 cancels out. I get 3v plus 4 equals 3v plus nothing. If I try to solve that, I would go ahead and subtract that 3v and get 4 equals 0v. Well, we know that nothing times 0 is going to give us 4. So there's one of those no solution ones. All right, 10, 11, and 12, solving a word problem with two unknowns using a linear equation. If we have two unknowns, we have to have two equations, a system of equations, in order to solve them. And so it says, on Friday, a local hamburger shop sold a combined total of 308 hamburgers and cheeseburgers. I like to use variables that make sense to me, so I'm going to use H for my hamburgers and C for my cheeseburgers. And if they sold a total of 308, it would mean if I took the number of hamburgers plus the number of cheeseburgers, I should have 308 altogether. The second sentence says the number of cheeseburgers sold there was 3 times the number of hamburgers sold. So when I read that, I want to look for the one that's mentioned first in my equation. The number of cheeseburgers sold. So the cheeseburgers is going to be set equal to something in terms of the hamburgers. The cheeseburgers. The number of cheeseburgers sold there was 3 times the number of hamburgers. 3 times the hamburgers, 3 H's. I'm going to solve this one by substitution. Since the C is set equal to 3 H's, I can get rid of the C and replace it with 3 H's. So now I have H plus 3H equals 308. And that's pretty easy to solve. I'm going to start by combining my like terms. 1H plus 3H would be 4H equals 308. And so in order to solve that, we just have to go ahead and divide by our 4. 308 divided by 4 gives me 77 hamburgers. Now I have to be careful to make sure I answer the question. This one says how many hamburgers were sold, but it could have asked me for how many cheeseburgers were sold. If it had asked me for the cheeseburgers, I'd have to go over here and multiply by 3. It didn't, so this is just going to be my answer. 77 hamburgers were sold. Number 11, a washer and a dryer cost $804 combined. Again, I'm going to use W for the washer, D for the dryer. So my washer's price plus my dryer's price was $804 altogether. The washer cost, the washer was mentioned first. So the washer costs is $98 less than the dryer. If I'm doing $98 less than something, I'm subtracting $98 from the price of the dryer, not starting with $98 and subtracting the dryer. I would get a negative number that way. So $98 less than something, I'm subtracting 98 from the dryer. Again, since this is solved for the washer, we can get rid of the washer and replace it with the D minus 98. And so our equation says D minus 98 plus D equals 804. Really don't need the parentheses since there's no signs in front of that. I could put them there if I wanted to, but I'm going to go ahead and combine my like terms. D plus another D would be 2D minus 98 equals 804. I have to go ahead and add my 98 to move that over to the other side. So 2D is going to equal 804 plus 98, which is 902. And then I'm going to go ahead and divide by 2. 451. So the dryer cost me $451. What is the cost of the dryer? That is the one I want. Had they wanted the washer, I would have had to subtract 98, but I did find the right one, and so 451 would be my answer. So just be aware that you could have the other one, and that you got to make sure that you're answering the question that they're asking. Do they want the washer or do they want the dryer? Just because you got to the end of your solving your equation doesn't mean that's the one they're asking for. So number 12. A total of 584 tickets were sold for the school play. They were either adult tickets or student tickets. So I'm going to use A for my adult, S for my students. I'll just have to try to make sure it doesn't look too much like a 5. So my number of adult tickets plus my number of student tickets would be 584 altogether, since there were a total of 584 tickets sold. The number of student tickets sold, so S, is going to be, was 3 times the number of adult tickets. So S is going to equal 3A, pretty similar to that very first problem we did. If my student tickets is 3 times my adult tickets, I can replace my student tickets with 3 times the adult tickets. So A plus 3A equals 584. And when I combine 1A plus 3A, I get 4A to equal 584. And then, of course, I have to divide by 4 in order to solve that. 584 divided by 4 is 146. So we had 146 adult tickets. How many adult tickets were sold? We got lucky again. That's the one they were asking for. So 146 is my answer. 13, 14, and 15, solving a decimal word problem using a linear equation in the form of AX plus B equals C. So, Reuben rented a truck for 1 day. There was a base fee of $16.95. There was an additional charge of 81 cents for each mile driven. Reuben had to pay $139.26 when he returned the truck. For how many miles did he drive the truck? So M is going to be the number of miles. How many miles did he drive the truck? So that gives us a good hint when we read about the miles in the word problem that we probably have to insert a variable there. Reuben rented a truck for 1 day. There was a base fee of $16.95. So right away he had to pay $16.95 just to rent the truck. There was an additional charge. So I'm going to add. The additional charge is 81 cents for each mile driven. I have to take 81 cents times the number of miles I drove to find out the charge. Be careful, this is in dollars, so 81 cents would be 0.81 times the number of miles, so 81 cents times M would give me my additional charge. When he returned the truck, he had to pay $139.26, so that was his total. We now have our linear equation, And again, your calculator is always active on the word problem, so I suggest you use it just so you don't make a silly calculation error. 139.26. I've got to minus my 1695 to move it to the other side. So 81 cents M equals 122.31. So what happened here, I took the total and took off my base. The extra I had to pay for my mileage was 122.31. So if I paid 81 cents per mile, I'm then going to divide that by my 81 cents. And that's going to give me the number of miles. 151 miles is how many miles I drove the truck. Number 14, Ashley received an $80 gift card for a coffee store. She used it in buying some coffee that was $7.56 per pound. After buying the coffee, she had $42.20 left on her card. How many pounds of coffee did she buy? So she started with an $80 gift card. She bought some coffee, which means the gift card balance is going to decrease. She had to subtract off the amount that she had on her card. She bought coffee that was $7.56 per pound, and we want to know how many pounds of coffee she bought. So $7.56 times the number of pounds. You can use C for coffee or whatever makes sense to you, but I'm going to use P. What she ended up with was $42.20. So now I have my equation. So I'm going to go ahead and solve that. So I'm going to start by subtracting my $80. And yes, I'm going to have a negative value, but that's okay because I have a negative 7.56p here. And we know that when we get a negative divided by a negative, it ends up giving us that positive answer that we want. So 42.20 minus my 80 is negative 37.80. If I take that negative 37.80 and divide it by my negative 7.56, I get P equals 5. So I know she bought 5 pounds of coffee. Number 15 should be the same kind of thing. So it says, for his long-distance phone service, Tony pays a $6 monthly fee plus 8 cents per minute. Last month, Tony's long-distance bill was $20.16. For how many minutes was Tony billed? So his monthly fee was $6 plus 8 cents per minute. 8 cents. 0.08. Not 8, not 0.8, 0.08. 8 cents per minute. So 8 cents times the number of minutes that he was billed for. The bill ended up being $20.16. So again, if I go ahead and solve that, I'm going to start by subtracting my $6. So 8 cents times the number of minutes equals $14.16. That was the amount that he paid for just the phone calls without the monthly fee. And if we take our $14.16, divide it by our 8 cents per minute, the number of minutes was 177. (16, 17, and 18, solving value mixture problems using a linear equations. These are ones usually where you have a cost times the amount, and you're going to set up a system of equations because you have two unknowns. It says at the City Museum, a child's admission is $5.30 and an adult admission is $8.80. On Wednesday, 154 tickets were sold for a total of $1,050.70. How many adult tickets were sold? So A is going to be my number of adult tickets. C is my number of children's tickets. So two equations. One has to do with the money. One has to do with the number of tickets. My first equation, I'm just going to have the number of tickets because that's what my question says. How many adult tickets? My number of adult tickets plus my number of children's tickets was 154 tickets altogether. On the next part, with the money, if I take $5.30, whoops, on my children's tickets, I'm going to switch that around. I'm going to line that up with my C. So $5.30 on my children's tickets and $8.80 on my adult tickets, my total that I took in, $1,050.70. Now you can solve this problem either by doing the substitution method or the elimination method. I'm going to show you the substitution method first, and then on a different question I'll show you the elimination method, and you can decide which way you like better. So, substitution method. I want to find the number of adult tickets. So I'm going to take this first equation and solve it for the opposite thing. If I want to solve it for if I want the adult tickets, I need to solve this one for the children's tickets. So I'm going to move my A to the other side, and C is going to equal 154 minus A then. Now what I'm going to do is replace the C in the second equation with the 154 minus A. So if I rewrite that second equation, 880A plus 530 times 154 minus A is going to equal 1,050.70. Now I can go ahead and use my distributive property. So 880A plus 530 times 154 $816.20 minus 530A, using my distributive property here, equals 1,050.70. Combining my like terms, 880 minus 530 would give me $3.50 A. I'm going to go ahead, besides combining my like terms, moving my 816.20 to the other side, just because I'm running out of room to write. So 350A is going to equal 1,050.70 minus 816.20, which is $234.50. So in order to solve that for A, how many adult tickets were sold, I can divide by 350. Divide that by 350, and I get 67. So A equals 67 adult tickets were sold. Now, had I accidentally solved that for the wrong variable, of course I could have went in and substituted and found the other answer. But if you take that first equation and solve it for the opposite thing so that you can replace that variable in the second equation, then you'll get the one that you want for your answer. So number 17. Abdul's coffee shop makes a blend that is a mixture of two types of coffee. Type A coffee cost Abdul $5.85 per pound. Type B coffee costs $4.65 per pound. This month's blend uses 3 times as many pounds of type B coffee as type A coffee, for a total cost of $514.80. How many pounds of type A coffee were used? So this one, unlike the first one, doesn't have a total of how many pounds, but it does tell us in that second sentence that this month's blend uses 3 times as many pounds of type B coffee as type A coffee. Again, when you're reading that, whatever item is mentioned first, in this case, type B, is going to be written in terms of the other one. So 3 times as many pounds of type B as type A means B is going to be equal 3 times A. It's a tricky kind of thing, but whatever one's mentioned first, that's the variable that's by itself. My other equation, $5.85 per pound for type A coffee and $4.65 per pound for type B coffee. My total cost, $514.80. So this one we have to solve by substitution. We're going to replace the B with 3A. And just to save myself some room, I'm not going to rewrite it. I'm just going to multiply that out. So 585A plus 465 times 3A. So 4.65 times 3 is 1395A then. Equals our 514.80. We can combine those like terms. So 1395A plus our 585 is 1980. So 1980A equals 514.80. And of course, we're going to divide in order to solve for A. So if we take our 514.80, divide it by our 1980, we get 26. The question, how many pounds of A were used? 26 pounds. If it had asked me for B, I would have had to multiply that by 3, but it didn't, so I won't. Oops. Oh, it thinks my pen isn't where it's supposed to be. I better put it in the right spot. Now we'll see if I can move it. Number 18 then says a web music store offers 2 versions of a popular song. The size of the standard version is 2.2 megabytes. The size of the high quality version is 4.8 megabytes. Yesterday there were 1,050 downloads of the song for a total download size of 4,000 megabytes. How many downloads of the high quality version were there? So we have a standard version and a high quality version. So S is going to be my number of downloads for the standard. H is my number of downloads for the high quality. How many downloads? Well, we know there was 1,050 downloads total of the song. So the standard plus the high quality would equal 1,050. We also know the size. If each of my standard songs is 2.2 megabytes, then 2.2S would be the size for my standard downloads. Plus 4.8 megabytes for each of my high quality ones. Total number of megabytes says it's 4,000. Now, we solved number 16 by doing the substitution method. I personally prefer the elimination method, and although they're not going to talk about it till you do systems of equations, I'm going to introduce it here, and if you like to do it that way, go ahead and do it that way. We want to find the downloads for the high quality, which means we want to eliminate the standard version. So in order to eliminate it, we're going to multiply that top equation by the opposite of what's in front of our standard version so that when we add our 2 equations together, we get rid of the S's. So what I'm going to do is take this top equation, multiply it by a negative 2.2. So negative 2.2S, negative 2.2H, and then I have to take negative 2.2 times 1,050, which is negative 2310. Now I'm going to add my second equation with my new equation. 2.2 minus 2.2 is going to cancel out my S's. That was my whole purpose. 4.8 minus 2.2 would be 2.6H. And then I have to take my 4,000 minus my 2310. 1690. So in order to solve that, of course, I'm going to divide. And so if I take 1690 and divide it by my 2.6, I get 650. So how many downloads of the high quality version were there? There were 650 out of the 1,050, so that would make sense in terms of my problem. So 19, 20, 21 distance, rate, and time problems. What they want to get across is that the distance is equal to the rate times the time, and that when we're solving these, we might be doing one distance plus another distance to find a total distance, or we might be going somewhere and coming back where the distances are equal. We also have to be careful on these problems that just because we get it solved for one of the variables doesn't mean that's the answer to the question. So we always got to go back and say, what question do they want answered? So in this case, two trains leave the station at the same time. One headed east, so one's going to the east, the other's headed west. The eastbound train travels at 97 miles per hour. So for my eastbound train, if rate times time equals distance, I know that my rate is 97. My westbound train, 83 miles an hour. So again, rate times time equals distance, my rate is 83. How long will it take the two trains to be 288 miles apart? How long? What is their time? Well, if they left at the same time, they're going to be 288 miles apart at the same time. So I'm just going to use t for their times. So 83 times t is the distance of the westbound train. 97 times t is the distance of the eastbound train. If I add their two distances, I should end up with 288 miles apart. So I'm going to go ahead and combine my like terms there. If I take 83t plus 97t, I get 180t. So 180t should equal the 288 miles that they're apart. In order to solve that for t, I'm just going to go ahead and divide. So 288 divided by 180 gives me 1.6. Do not do any rounding. How long is it going to take them? This is in miles per hour, so it's going to take them 1.6 hours in order to be 288 miles apart. The next one. Two cars leave town 600 kilometers apart at the same time and travel toward each other. So this time one's going this way and one's going this way. One car's rate is 12 kilometers per hour less than the other. So one of the car, I'm just going to use R for its rate. We don't know what the rate of the first car is. The rate of the second one is 12 kilometers per hour less than the other ones. So 12 less would be R minus 12 for its rate. So one rate R, the other one 12 less than that, so R minus 12. If they meet in 3 hours, that means this one went for 3 hours, this one also went for 3 hours. Again, we know that they met and that their distance was 600 kilometers because they met in the middle, and so 3R plus 3R minus 36, using my distributive property, is going to equal the 600 miles they're apart. 3R plus 3R would be 6R minus 36 equals 600. If I'm going to solve that, I have to add my 36. So 6R equals 636. And then, of course, I'm going to divide by 6. So 636 divided by 6 is 106. R equals 106. Now, it wants you to find the rate of the slower car. You found the rate of this car right here, If this one is doing 12 less than that, it's going to be the slower car, right? So I have to take 106 minus 12 in order to find the rate of the slower car. 106 minus 12 is going to give me 94. Now this is in kilometers per hour, so you're thinking, oh, they're going really fast. But remember, kilometers per hour is not the same thing as miles per hour. And so you have to be careful. Just because you found one of the rates doesn't mean that that's the rate that they want you to put for the answer. That one's going to be faster than the other one. Number 21. Kiko, or however that's pronounced, drove to the mountains last weekend. There was heavy traffic on the way there, and the trip took 12 hours. When Kiko drove home, there was no traffic, and the trip took 8 hours. If her average rate was 20 miles an hour faster on the trip home, how far does she live from the mountains? So she's leaving home, going to the mountains, then she's going to come back and go back home, right? Still, we're thinking about rate times time, but this time those two distances should be the same. So there was heavy traffic on the way there, and the trip took 12 hours. So my time here is going to be 12 hours. There was no traffic on the way, or when Kiko drove home, there was no traffic, and the trip only took 8 hours. So on the way back, her time's only 8 hours. Her average rate was 20 miles an hour faster on the trip home. So again, we don't know what the rate was on the way there, but on the way home, we know she went faster, and so we have to do R plus 20. So here, the rate on the way there is 12R. The rate on the way back would be 8R plus 160 if I use my distributive property. And so, or the distance. The distance on the way there is 12R. The distance on the way back, 8R plus 160. And those two distances should be equal. So if I want to solve these, I'm going to subtract my 8R. 4R equals 160, and then I'm going to divide by 4. So R equals 40. So, we found the rate on the way to the mountains. The question doesn't ask for the rate. The question says, how far away does she live from the mountains? So, if her rate was 40 and she went for 12 hours to get to the mountains, we have to take 40 times 12, the rate times the time, in order to get to the distance to the mountains. So 40 times 12 gives me 480 miles. So these ones are going to be kind of tricky because they do all kinds of twists and turns in there. Just keep writing down your examples so that you have plenty of examples to follow, and hopefully you will be able to catch on to these ones. Alright, solving a percent mixture problem with a linear equation. This kind of leads into some things you might do in science class. It also has to do with some investments. And sometimes you can set up your equations without having a table, but sometimes an equation or a table helps you set up your equation. So what you're thinking about when you're doing these problems is usually you're going to have two things. I'm going to say A and B in this case, since I can see she has fund A and fund B. And sometimes you need to keep track of some totals. So what you're going to have is you're going to have an amount times a percent to equal the part or the pure substance or something like that. So it says Rachel invested her savings into 2 investment funds. The amount she invested in A was 4 times as much she invested in B. So we don't know the amounts for either of them. Since they're putting A in terms of B, I'm going to put the amount in B is B, and the amount in A is 4 times the amount she put in B, right? The amount she invested in fund A was the 4 times what she put in B, so 4 times B. Fund A returned a profit of 6%, so 0.06. Fund B returned a profit of 5%, so 0.05. We know that the total profits together was $3,480. So, if I take 4B times 6%, 4 times 0.06 is going to give me 0.24B. If I take 5% times B, I'm going to get 0.05B. So my equation is going to be that (0.24B) plus 0.05B equals 3,480. So 24% plus 5% here. 24% plus 5% would be 29% B to equal my 3,480. All we need to do to solve that then is to go ahead and divide. 3,480 divided by 0.29 gives me B at $12,000. How much did she put in B? So again, we did find the right answer. Had they asked for A, we would have had to multiply that by 4, but they asked for B, so $12,000 is just going to be my answer to that question. I like have to sneeze. Number 23 then, going to be the same kind of thing. I'm going to go ahead and set up my table. Again, I have plant A and plant B. So I have A and B, and I might need to keep track of some totals. I'm going to have my amount times my percent to equal my part. Maybe should have made my boxes a little better, but bigger, but it says 2 factory plants are making TV panels. Yesterday, plant A produced 5,000 fewer than plant B. So same kind of thing as on the last one. We don't know how many B has. We're just going to call it B. We know A is B minus 5,000, right? 5,000 fewer than B. 4% from A, so 0.04, and 3% from B, 0.03. Were defective. How many did B produce if there were 920 defective panels? So the total number defective was 920. I'm going to make my boxes over here just a little wider because I don't think it's going to fit otherwise. So here again, I'm going to use my distributive property and multiply that out. 0.04B minus 4% of 5,000. 200. This would be just 3% of B. So we know 0.04B minus 200 plus 0.03B is going to equal 920. So combining our like terms, 4% plus 3% would be 7% of B minus 200 equals 920. Solving for B, we'd have to add our 200. So 0.07B is going to equal 1120. And then we have to divide that by 0.07. $16,000. How many panels did B produce? They produced 16,000 panels, and only 3% of them were defective, but 16,000 is the total number of panels that they had, not the number of defective panels. So if it seems kind of big, it should be. 24, same kind of thing. we have A and B again? Yep, we have A and B again. My totals, my amount, my percent to equal my part. So Dal invested his savings into 2 investment funds. The $8,000 he invested in Fund A returned a 10% profit. So we know that in Fund A we had $8,000 and that we made a 10% profit from Fund A. The amount he invested in Fund B returned a 3% profit. How much did he invest in B? We don't know. We're going to put a B there. How much did he invest in B if both funds together returned a 7% profit? So both funds together would be 7%. How much did he put in both funds together? Well, he put in $8,000 in A and B in B. So $8,000 plus B is the total amount he invested. So filling in our column, $8,000 times 10% means he got $800 in profit. Here we're going to have to take 3% times however much was in B. And again on the end I didn't quite make my box big enough because we're going to have to use our distributive property. 8,000 times 7%, 560, plus 7% of B, right, using my distributive property. So the part that he made in A plus the part he made in B should equal the total profit that he got all together. And so now I have my equation. Solving that, I'm going to subtract my 560 and subtract my 0.03b, just so I don't have to worry about negatives. I could move them the other way if I wanted to. 800 minus 560 would give me 240. 7% minus 3% would be 4% of B. And so if I take 240 and divide it by my 0.04, B is going to be $6,000. How much did he invest in B? $6,000.